Right, here we go, guys. Last page of this lovely packet. And I'm being serious when I say lovely. I do love the problems in this packet. I really think they make you think. And they just really reveal if you actually know what's true about these shapes or not. On this page, there are two problems that use... Okay, well, I was going to say that use algebra. That's a lie. Obviously, they all use algebra to solve equations. But for letter A, you're going to need to solve a system of equations. And for letter D, to solve for y, you'll actually need a little bit of algebra too. It's a problem like I covered... I know I made a video going over... I can't remember. It might have been earlier in this packet. But let's get started. So these first four shapes are parallelograms. So what do we know about parallelograms? We know that opposite sides are congruent. We know opposite angles are congruent. We know consecutive angles are supplementary. And the diagonals bisect each other. So for letter A, I know that 14 equals... actually, I'm going to write it out like this. 2x plus 3y equals 14. And 8x minus y equals 4. So since you have two variables in one equation, that means you need two equations to solve. So we have to solve this system. So again, solving systems of equations in Algebra 1, three methods that you can use to solve: elimination, substitution, or graphing. Because these are both in standard form, elimination is the most efficient way. So I'm going to multiply this equation by 3. Give me 24x minus 3y equals 12. I'll get rid of that, and I'm going to add these two equations together. So I have 26x, y's cancel out, equal 26. I get x equals 1. Then you can just plug that into either of your equations then to solve for y. Once you do that, you should get y equals 4. All right. Letter B, this one's a little bit easier. Opposite angles are congruent, so 120 equals 3y. So you get y equals 40. For this expression here, I know that these two angles add up to 180. So I can set 5x plus 10 equal to 60. And then once you solve that equation, you should get x equals 10. All right. For letter C here, I know that these three angles add up to 180. Okay, that doesn't help us. Oh, yes, it does. Because this is 78 degrees because that they are alternate interior angles. So that tells me that y is going to equal 52. And then x would just be congruent to that angle because opposite angles are congruent. Okay, for letter D, I know that x squared plus 5 equals 9. And I know that, right over here, y squared equals y plus 6. This is like the Algebra 2 problem. This one's pretty basic. You can definitely solve this guy. So you get x squared equals 4, and when you square root both sides, you get x equals 2. Now for this, this is also a quadratic equation like this one was. This one we could just solve by taking square roots, which you've covered in Algebra 1, and you know how to do that. For this one, because I have a y squared and a y, I can't just solve by taking the square root. So we're going to solve this by factoring. I'm going to first move my y and my 6 to the other side. I want my y squared to be positive, and I want 0 on the other side of the equation. So we're going to have y squared minus y minus 6 equals 0. Okay? Now at this point, you can just factor this expression, which that is an Algebra 1 skill that hopefully you remember. But you're looking for two numbers that multiply to negative 6 and add to negative 1. So that's going to give us y minus 3 and y plus 2, and that equals 0. So now if you have two things that are being multiplied together to equal 0, one of them has to equal 0. That's the only way that you'll get 0. So at this point, we can split this up and we can say y minus 3 equals 0, or we can say y plus 2 equals 0. So when we solve, we get y equals 3 or y equals negative 2. So those would be our possible answers for y. And I think both of them work in this case. This will be 4 and 4. Yep. Either answer would work. When you have a quadratic equation, like the highest exponent in your equation tells you how many possible answers you would have. So there's our possible answers for y. For x, we only got 2, but it's technically positive 2 and negative 2 that would work here. Okay. Let's move on to our isosceles trapezoids. So what do we know about isosceles trapezoids? We know that the legs are congruent. So there's our first equation. 3x squared plus 1 equals 28. You don't need algebra 2 to solve this. If we subtract our 1, we get 3x squared equals 27. Divide that by 3. Get x squared equals 9. Square root that. X equals 3. Okay, now what about y? Well, for isosceles trapezoids, we know that the base angles are congruent. So this is also 5y, and this is also 135. So we know that 5y plus 135 equals 180. These are same side interior angles. So then when you solve for y, you get 9. Okay. Now this last one, I don't know if you can see my markings. I started marking stuff in before I made the video. I'm not sure why. I think I was just making sure I knew how to do the problem, and then I didn't erase it. So, first I filled in this 30 here, because those are alternate interior angles. So then we have this triangle here, meaning x equals 100. And then, okay, so isosceles trapezoid, I know the base angles are congruent, so this angle has to also equal 50, meaning y was 20. So x is 100 and y is 20. Okay. And if you're wondering why this isn't 100 degrees, if you remember the method that we used in proofs with parallel lines and like finding the alternate interior angles, if you would highlight these parallel lines and make your z, if you remember that, these are your alternate interior angles. Okay, these are not alternate interior angles. You can see with this line here, it's just like making this angle and they're not alternate interior. Okay, there it is. Thanks for watching.